Welcome to Lesson 1 on the scientific method. Today I'm going to be presenting this lecture to you, and my name is Wendy Nofke. To start out with a quote to get things going in here. If I have seen a little further, it is by standing on the shoulders of giants, by Sir Isaac Newton. And that's really pertinent in science today, because what this quote tells us is that science is a matter of continually going a little bit further and exploring new things, but we wouldn't be able to explore the new things that we do today without the knowledge that we've acquired from those before us. And part of using that knowledge in a useful way is through the scientific method, which is what we're going to talk about today. So first, let's define what is science. Science is the study and comprehension of natural phenomena. Science is closely tied in with technology. Technology is the application of science. What we probably notice more in our day-to-day lives is the convenience that technology has brought us. But we wouldn't have that technology without the scientific background in order to discover what we've used for that technology. Part of what's allowed us to advance the field of science and technology so much is scientific skepticism. And scientific skepticism involves questioning claims rather than accepting them based on faith and anecdotes. By questioning the claims, we can go through and actually make sure the information is correct and valid before applying it. All of the scientific method is set up to try and lead you to question as you go through, so that what we make our judgments on is information that's accurate to the best of our knowledge. So when we talk about scientific theories and scientific laws, a lot of times there's some confusion. There's confusion between what the term hypothesis actually means. Your hypothesis is a proposed explanation made on the basis of limited evidence as a starting point for further investigation. The hypothesis is actually very early on in the process. Oftentimes people think the hypothesis is just an educated guess, and that there is no wrong explanation for a hypothesis. In the scientific field, we do really try and make sure that it is an educated guess and that we do our research before actually testing out our hypothesis, because often it is quite expensive to carry out these procedures. A scientific theory is a well-substantiated explanation of some aspect of the natural world that is acquired through the scientific method. It is also repeatedly confirmed through observation and experimentation. A lot of times people will use the term theory to imply that there is a lot of doubt in the scenario. But in science, a scientific theory actually does not have a lot of doubt in it. While it's very difficult to prove something true in absolutely all circumstances, a scientific theory actually has a tremendous amount of research and experimentation behind it before we ever call it a theory. The scientific law kind of takes things to the next step. It's a statement based on repeated experimental observations that describe some aspect of the world. And it always applies under the same condition, and it implies that there is a causal relationship involving its elements, so that one thing definitely leads to another. There are some questions that are not answered by science. Things that are matters of beliefs or religion, things that involve supernatural phenomena, moral issues, and the meaning of life. So science just is not able to, we have no way of having absolute proof, so science is not able to go through and prove those things. So when we look at the facts in there, we have the option of using inductive or deductive reasoning. Deductive reasoning determines a single fact from a general statement, and it's only as accurate as the statement. Inductive reasoning determines a general statement from several individual facts. In science, we try to use deductive reasoning as much as possible. There are some problems with using inductive reasoning. With inductive reasoning, the truth of the reason does not guarantee the truth of the conclusion. And with inductive reasoning, it's going to involve reaching conclusions about things that were not observed. So the accuracy is not as great with inductive reasoning. So what happens when we find some disagreement in the prediction of long-standing theories? So some examples of things like this were, for years people believed the Earth was flat. And we have since learned that it is not. Another example is classical mechanics. Newton's laws were accurate to explain mechanics for most of the human experience. However, they did not apply for things that are beyond the human experience. So things traveling at very high speeds, like the speed of light, or things traveling in space in a vacuum. The relativistic mechanics that were Einstein's law, these ended up being accurate for the human experience that Newton's laws explained and beyond. So sometimes as we build on our knowledge, we have to make some modification and update our long-standing theories. So what exactly is a scientist and what do they do? There's a lot of misconceptions about this. A lot of times people think scientists are always found in the lab and never leave the lab. Scientists actually come from a wide variety of backgrounds and work in a wide variety of fields. They will work in many different occupations. So scientists can have really fun jobs. A lot of times they're very happy with what they're doing. Some of their jobs can be indoors, but they can also have jobs that are outdoors. You may do research. You may end up working with people a lot. You may end up working with a computer a lot. There's a huge variety of information out there on different scientific careers. Scientists must be good at communicating and cooperating with many other professions, since often scientists do not work alone. There are several different branches of science. These are just a few. Biology, which is the study of life. Physics is the study of how things happen. Chemistry, the study of matter. Astronomy, the study of space and the stars. Ecology, the study of the environment. Geology, the study of the earth. Taxonomy, the study of naming things. And then we also have a relatively new field out there of genetics.